We are going to examine the Arellano and Bond technique that deals with the endogeneity problem. We will follow this study by Brown 2009 and others published in the Journal of Finance that we need to model the R&D dynamic. For clarity, R&D stands for research and development. Now let me select the initial variables for this model. Therefore, I'll be utilizing the Finance Research Gate website, specifically with a single frequency on an annual basis. Let's begin with the recent period of 2000 and conclude in 2024, and then we'll apply that entire period. So when we're looking at the financial statement variables, especially in a case like ours, you'll often find that a firm's data typically commences around 1996. Now, let me go ahead and select the X variables for our analysis. The very first one I'm going to choose is net stock issues. Additionally, it's crucial that we establish a clear and effective measure for our sales performance. For this purpose, we have decided to utilize the asset turnover ratio, which fundamentally indicates how efficiently a company is using its assets to generate sales revenue. And in addition to that, we will also be incorporating a relevant cash flow variable. In addition, let's consider other potential variables for splitting, such as age or perhaps even size, which we might find useful to incorporate into our analysis at a later stage. However, it's important to note that these three X variables are currently our primary focus. The Y variable is defined as the R&D intensity, specifically the research and development expenditure scaled by the company's total assets. Once we have completed that, we can then proceed to log the X variables.
So what we'll need to do next is apply a lag operation to all of the X variables. And then we will add them together. When we examine the descriptive analysis, it's possible to find some outlying data points, and we must then address them with appropriate techniques.
Vectorization.
We should proceed to convert all of the data points and parameters that we currently possess into a vectorized format. And we should probably choose the 1% significance level.
Once we are done with this, we will be all set, and then we can finally begin the simulation. But before we do that, we really need to carefully examine the core idea behind this technique. So, if we are considering a dynamic model where we incorporate the lagged value of y as an independent explanatory variable, then it becomes crucial to address the potential problem of endogeneity. So, in this particular analysis, we are considering the research and development, specifically the lagged R&D. And then we also have the independent X variables, such as sales performance, cash flow, and any stock issuance concerns. And here we see the firm fixed effects, and alongside that, we have the error term. Now, to effectively eliminate these firm fixed effects, our approach involves taking what's known as the first difference. This essentially means calculating the difference for each individual firm in a specific year compared to its value from the preceding year. Through this particular firm transformation, we will be able to remove the AA term because this AI factor is fixed and constant over time, so when you compute the first difference, it will mathematically disappear completely. So we're looking at this particular equation. Now, a very fundamental principle in the entire field of econometrics is that any X variable must not be correlated with the residual error term. But that is violated here because the lagged research and development is not adequately addressing the current challenges. This statement is correct because the lagged level of research and development is composed of two distinct parts, the portion explained by any given model and the idiosyncratic component, which essentially represents the error term. Therefore, the error term we're discussing is inherently built from, and thus directly includes, a component derived from the previous period's level of research and development. This means that the error term itself contains a portion of this specific variable we are analyzing, and as a direct consequence, this will inevitably cause the entire term we're examining, specifically the full X term, to become significantly correlated with the error. And that, in essence, is the fundamental source of this endogeneity issue. This means that if we attempt to use ordinary least squares, our estimates will inevitably be biased, primarily due to the fact that the independent variable X is correlated with the error term. The Arellano and Bond approach will effectively resolve this issue by utilizing the instrumental variable method. For this particular situation, we'll be utilizing the second lag of our research and development efforts, or perhaps even earlier lags. It might potentially be 3 years or perhaps 4 years, depending entirely on the specific error structure and its correlation. We begin with a delay of 1 second, and there are two specific requirements that must be met before we can utilize any instrument. We need to consider both the relevance and the exclusion criteria. The relevance principle states that any chosen instrument must be directly related to the primary endogenous variable. For our particular analysis, the endogenous variable is specifically the first lag of R&D. This specific variable is the endogenous one that is correlated with the error term. So we need a suitable replacement or a proxy for it, and we will use the second lag. Is it correlated? Yes, it is, because by its very construction, we are modeling the dynamic behavior of the y variable, which is inherently serially correlated, at least with a single lag period. This is precisely why we are including the lagged R&D in the first place. So, by its very design, the R&D variable at time t-1 is established with a lagged period. Therefore, in this specific instance, the research and development variable with a 2-year lag is generated. This is similar to a development variable with a 1-year lag, as there's just one lag period between them. And yet, it's important to note that we have an autoregressive path for the y variable. This is precisely the reason why we are including the lagged R&D in our analysis in the first place. So, yes, R&D t-2 is created with R&D t-1, and therefore we use that as an instrument for our difference variable here. That is endogenous. The second condition is exclusion, or trigger per. And this means that any instrument that you are using must not be correlated with the error term. So, when we look at the error term in this specific model, we are considering two distinct components. First, the error from the current period, and then the error from the previous period, which is often denoted as t-1. Therefore, it is crucial that our chosen instrument does not show any correlation with either the current error term or the lagged error term. And this is precisely the situation because our research and development or any other independent variable cannot possibly be correlated with future errors unless there is an inherent autocorrelation among those errors themselves. If there's no error autocorrelation present in the model, it means by its very definition that the x variable or any other instrument variable we might consider cannot possibly be correlated with the future error term. So we can therefore plausibly assume that this condition is indeed met. So that's the core idea, the underlying principle we're focusing on. And with that understanding, we can then proceed to go back and execute the Arellano unbound model. Our next step involves navigating to the appropriate section and carefully selecting the y variable, which has already undergone a specific transformation designed to effectively mitigate the influence of any potential outliers. It appears we must undertake the entire selection procedure once again. Consequently, I will now proceed to introduce the appropriate delays. And once we have successfully identified these specific lags, it appears we might have overlooked or lost track of them initially, so we can proceed to rectify this situation without delay. Therefore, we will need to re-enable the realization function once more.
And we simply need to define the variable
We selected the y inside the advanced regression, and then we are going to select all of the independent variables that we believe are most relevant for predicting our outcome, carefully considering their potential interactions and ensuring our model is robust and interpretable, which is crucial for drawing meaningful conclusions from our analysis. The x, which has now emerged and is already falling behind. When we considered the overall sales turnover, the very important cash flow to price ratio, and any net stock issues. Once we are completely finished with this, we can then scroll down the list and carefully select the Arellano unbound option. So here we have the lagged y variable and also the lagged R&D. What's truly important is that the result is significant, which clearly demonstrates the crucial importance of having used the lagged y right from the very beginning. It is in fact quite significant. However, when we examine the other coefficients in our analysis, we observe that they do not exhibit a statistically significant p-value, which is an important consideration. Nevertheless, this particular estimation method has the potential to effectively address and resolve the issue of endogeneity, provided that the evidence presented within this table conclusively demonstrates its capability. So, in this particular scenario, we examine the Hansen test, specifically the Hansen-Sargan test. And the result of that test, if it is found not to be statistically significant, then clearly indicates that our chosen instrument variable is not correlated with the error term, which is a crucial and desirable outcome for satisfying the exogeneity condition. So, the relevance condition is established by examining this particular coefficient, which indicates the presence of an autoregressive path for the y variable. Specifically, the R&D at time t-2, as presented in our PDF document, shows a clear correlation with R&D at time t-1. The other crucial point we must address here is the concept of exogeneity. As I've already stated, this particular result is not statistically significant, which strongly suggests that our instrument variable is not in fact correlated with the underlying error term. This lack of correlation is evident because the calculated p-value itself is not statistically significant.
So, the null hypothesis in this situation is that all instruments you are using are not correlated with the error term. Our analysis leads us to fail to reject the null hypothesis, which then means we can confidently proceed forward and safely assume that our chosen instruments are indeed not correlated with the error term. The second important aspect that you absolutely need to verify is the presence or absence of error autocorrelation. In this context, it's quite common to observe a value that is statistically significant, and it can even be a negative value. It's crucial to understand and remember that the error autocorrelation specifically pertains to the change or difference between errors rather than the absolute magnitude or level of the errors themselves.
So what does that mean?
Now, if we were to consider going back to this specific point in our discussion, and your primary objective is to accurately determine the statistical covariance of the observed differences between the various errors, you will then find yourself utilizing this particular mathematical equation, especially when you are working with or constructing the very first autoregressive model. So, in this particular scenario, if you proceed to solve this specific mathematical equation, what you will ultimately find is a result that represents the negative value of the variance associated with the error term, and more precisely, this refers to the variance of the lagged error term. However, if you encounter a situation where there's an error correlation present within the level form of your data, then the AR, the autoregressive component of the difference error term will not be effective or appropriate.
It will be zero because one of these terms will eventually become a specific numerical value.
Therefore, the thing we should be focusing on isn't the initial one, autoregressive correlation, and also the difference in the error, because that is usually quite significant. We are particularly concerned with the second observation because if its significance is confirmed, it indicates the presence of error correlation within the level form, and consequently, we might need to consider employing a lagged instrument. So, in our particular situation, we initially employ the second lag of R&D. However, it might become necessary to consider utilizing the third or even the fourth lag, or perhaps we should use alternative instruments within our systems equation.
So, in this particular case, the p-value is not statistically significant, which is a very good sign, meaning that we do not have a significant autocorrelation and the error term is appropriately leveled. Therefore, all the prerequisites have been established for utilizing the Arellano unbound approach, enabling us to apply the coefficient and subsequently formulate the interpretation. The final point to consider is that you can execute the exact same equation by simply enabling the necessary sample splitting feature. For instance, we have the option to apply this specific equation, considering the age factor, perhaps comparing younger companies against more established, older firms. Alternatively, we might conduct the analysis by categorizing them based on their operational scale, looking at small-sized entities compared to their larger counterparts. So for our purposes, I will proceed with this particular approach.
All right, I'll just go back to using the original variables. It appears we've somehow lost them.
So the next step we need to take is to perform the actual splitting operation.
And from there, you can split this data based on any variable, including factors like age or size, or you could even use the category. For example, if you want to conduct an analysis distinguishing between high-tech firms and low-tech firms, you can certainly do that. Once you've completed the categorization process in this area, then you'll have the option to make a selection. For example, I could then proceed to work with sectors. And once I've chosen specific sectors from this list, I can then proceed to select the exact industry that's most relevant to my needs. So that concludes our overview of the Arellano Unbound system. For now, in our next upcoming video, we will be delving into the details of the system GMM, specifically focusing on the bundle unbound approach. Thank you very much for watching.